So now we're going to deep dive a little bit with Reid about how the YUI project does our testing more specifically. Welcome, Reid.
Thank you. Hey guys, my name is Reid. I work on the YUI team at Yahoo. And for the last year, I've been working on improving how we test YUI. And it's been really great, and I'm really looking forward to sharing everything that we've done in the last year with you guys. So if this isn't the first time I've talked about this, and last year it was really great for me to talk last year about the whole purpose about why people test. And if you didn't catch my talk, or this is your first time at YUIConf, I'd encourage you to look at least the slides from my last talk, where I go over the whole point of what testing fulfills and what role testing has when writing code. But it is useful, even though the point of my talk last year was basically that the testing isn't your goal. Your goal is to write code that does what it's supposed to do, so don't go crazy with writing tests. But it is useful, and we do it. Everyone should be doing it. And like the last talk, the last talk was all about, it doesn't really matter what you call it. It's just really important that you do it in a way that helps you check for common mistakes. So again, you're not paid to write tests, and the really cool thing that's come about in the last, just as about 1 year ago, it became possible for us with different technologies that, from like Sauce Labs, for example, offered projects where open source projects could use their resources for free. And so we were really interested in that. And that basically let us test on all the environments that we supported in YUI. So it's really neat that now this is all possible. But to go over where we were a year ago, it was not so great what we were doing for testing YUI. So we had a single CI job, basically, which is simple, but had problems. We didn't use Yeti. We were using something else. We didn't test Ajax, so things like I/O had to be tested by hand. One browser was tested at a time. So in CI, we would only have one browser would have to run to completion, then go to the next one, then the next one. We only had unit tests, so no examples were being tested in an automated way, which is really painful. We only had 2 browsers and Node being tested in an automated way. And so what we wound up having was before release, we'd have to do this testing one way or another. And how we did that was a day-long, get everyone in the room and test the code, right? And you can see how this is kind of incompatible with doing rapid releases, right? So they had to go, we had to get rid of them, and we did. We had to, but in order to do that, we had to find a way where we can test the 15 target environments plus the stuff that we test because they're going to be on the target environment list soon, right? So, but there was a lot of problems that we had getting there. When you have one CI job, things are pretty easy. So another project I work on is Yeti. And so with Yeti, whenever something goes wrong, the only place that I have to test it on is Node, right? So whenever something goes wrong, I get one email that tells me that something's broken because there's only one CI job. And because it's so fast, all the testing's fast, I don't need to send out my testing across many different CI jobs, right? So I get an email. This is kind of ideal. I go get an email. I go look, and then it's pretty clear what broke, right? When you use Travis for pretty simple projects, right? But when you're wanting to have automation for 15 different real browsers, and when you have over about 7,000 tests for every single browser, every single one of those 15, that's over 100,000 that you would test every time you make a change. So we're getting beyond, if we had just one CI job, we'd be waiting hours, right? And we definitely can't do that. So we outgrew it. And then we had a whole bunch of other problems. But even though we outgrew it, we found a way to get over them, and that's what this whole talk is about, is how we overcame these challenges, even though we couldn't use this simple model. So introducing what we do now. We now have, just with a CI slave, right, we can test with Phantom.js and Node. So Phantom.js isn't really, we don't support it, but it's fast, right? So right away we can see if there's a problem. We use Grover to do this, which is an open source project on our GitHub. And then we test our in Node as well. With Selenium, we test every single IE, even IE6 is tested, all the way up to IE10, Chrome, Firefox, and we also use Sauce Labs. Like I said before, Sauce Labs introduced this very generous plan where you can, if you're an open source project, you can use their resources for free, and they'll actually help you out. And we approached them and said that we're totally interested and we want to use them as much as it makes sense. And they've been really awesome, and like we do use them for testing for the things that we can't yet use any other way. And so it's actually really nice, and we're hoping that we can use more of them in the future. So we use them for Safari and iOS. Also, if you guys are remotely interested in Sauce Labs, I'd love to talk to you. We actually have Sauce Labs stickers that are going to be on the registration table, and there's a whole bunch right here, and you can pick some up. And we have, they've also given us promo codes, so you can, if you're interested, if you don't have an open source project, yet you use YUI and want to test out what Sauce Labs does, they've actually are giving people here 2 months free. So you can evaluate it and check it out. So that's all up here. You can come see me afterward. So we no longer use basically a pile of hacks. We use Yeti to test our code. So what Yeti gives us is AJAX testing with built-in echo. So another project by Dave Glass. So we can now test YUI IO. We can launch browsers on Sauce and Selenium. We can run many browsers at the same time. So instead of testing one browser at a time, we can run 3 to 10 browsers or however many you want, all at the same time. And that's been really huge. It speeds up testing quite a bit. We can test our examples. And so what we have is 11 out of 15 of our target environments are tested every time someone makes a push to github.com. So our CI system takes that and runs it on 11, and the other 4 work with Yeti, but they're not yet automated. For example, you noticed in the last slides where I was talking about what we automate, Android isn't on there. And that's because we find it really difficult to get Android working in the way that is reliable in CI. So, but we can still test it before release, and we no longer have to go through every example. We can point Yeti at the examples and at the unit test, right? So we no longer have to have day-long sessions. We just do this right before release, and we're done. It's all automated, and it's awesome. And most of our environments are tested every single commit. So as soon as there's a problem with those, we can see immediately what went wrong, in theory. But it's that actually about 3 or 4 months into the year when we had all this, that even though we test everything in theory, it was really, really hard to find where the problems were happening. And I'll share that as the talk goes on. But the testing was fast. So with Yeti, we had 8 parallel instances of IE being tested, 3 parallel instances of Safari. So with that, we can do, we had parallel builds. So with parallel builds, we not only have each build running, say 3 to 8 browsers, but we would run many builds at the same time, right? So that would be something like a Travis job or like a Jenkins job, where once you make a commit, right, we have 4 or 5 of those running at one time, going through and then running themselves 8 browsers, right? So then also to recap, we test all this. So that's the large majority of our supported environments are just automatically tested. And this runs 3 hours of testing in under 90 minutes, and it's just getting lower as we tweak this and make this even better. So it's still pretty good. In 90 minutes, we know on the majority of our environments if something works or not. But it gets really hairy, right? So this is the in theory part, right? So the in theory part is kind of 2 things. One, even though we're running all these tests, even if there was no problems at all, then it's sometimes hard to get that information, out and see okay, so we have, all these CI jobs, right? How do we find out where the problem actually is? Because you no longer can just go to that one page, right, and find everything you need. It's now over dozens of pages. And then the other problem is that we have a lot of moving parts. So to give you an idea, we have 21 CI jobs, so 21 things in Jenkins, for example, and then we have 3 branches, so that's 63 jobs, right? We have then about, let's just say 3, like it can be up to 8, but 3 browser VMs. So that's 189 that could possibly be running at once. And then that's in order to run those VMs, you have to have the actual build slave machine VM that's actually running, running the tests. So that's about 252 machines, which means 252 ways things can go wrong, if not more. So testing is now really hard. Instead of just having about 4 machines in our last setup, we now have hundreds. Things go wrong. Things were flaky. We had too many stuff going on at one time, and we had way too many test results to make sense of all this. So the workflow for an engineer on our team was impossible. What they would get is an email that says something went wrong. There's a failure. You got to check something out because everything is totally broken. But like if you wanted to check out what the failure is, this is the information that we get. And really out-of-the-box stuff, in Jenkins isn't much better, if not just completely opaque. But like no one could understand this. Like what you care about is, did the changes that I just make break the build? And yes, it broke. Something broke, but you don't know what, right? And this is what we're dealing with, right? This is what most people in this room are suffering with. In Travis, you just see the build was broken. It doesn't even tell you about what tests. You don't know why it broke. Did NPM go down? You don't know. And so what we did is we tried to make it so that like if someone had to take action on something, we would call the build unstable. So the build's unstable now. Like that means that there wasn't any infrastructure problems. So somehow those 250 moving parts all meshed together perfectly, but now there's a test failure, right? So now we have, so that's great. Now this is something that engineers can take action on. Well, not really. So they go to the build, and they have to click on the test results link, which takes them here. OK, and this page takes about 30 seconds to load, usually. If you use Jenkins with anything more than 1 job, you know what I mean. Then you click on this page. OK, now we finally see test results. This is terrible. Like, no one should be doing this. It should say right in the email, ideally. But the other problem is that some of these tests that are failing are like what Andrew talked about in the community talk earlier. Some of these tests are failing because this is the first time we're running these tests on more than 2 browsers, more than IE and more than just an ancient version of Firefox. And so once we threw all this stuff together, we noticed that there were a ton of failures. And if you're not testing on all these things in an automated way right now, you're also going to run into this problem if you have more than just a few tests. And so this is just one example. Like we have these tests, sometimes they pass, sometimes they don't. We call those flaky. But the thing is, if these are failing, we don't need, engineers don't need to take action on it because it means that they're, not right away at least, because that person's commit didn't break they didn't cause this problem, right? These just are flaky. We address them and reduce the amount of flaky tests we have as much as we can every release. But the fact is, we have them. The good news, though, is that over 99.5% of our tests, I think it's 99.8 something, are not flaky. So out of the hundreds of thousands of tests we run, only 300 are flaky at all. And that's been getting lower and lower. But the problem is that those that tiny fraction of 1% is causing hell for our developers, and that's totally not acceptable. So this problem is repeated for those 63 jobs, right? So each one of those can have a flaky test or some kind of other problem, and then it spews out emails, and it's like, what are you going to do? So you have this problem. So what do? Well, at Yahoo, we have a dashboard for this, which is awesome. So we get to use the dashboard, and that's going to solve all our problems. Well, no. So we look at this dashboard, and so we want to know, the question we're asking here is, did my latest commit pass? Did the last thing that I push, did that work? And when you look at this, it doesn't answer that question at all, and it just makes you more confused. So what it's doing is it's just taking Jenkins jobs and then showing them the history. And that's useful. Yes, we see more information. We know more. It's not over a dozen pages, and it's fast. Like you go to this page, it loads instantly. But it just doesn't work out. Like you're looking at this, and you see there's no indication that the builds that you're looking at, the last build that ran is actually the latest code. So the other thing you don't know is that if it's yellow, is that a flaky test or not? We don't know. If it's red, was that an infrastructure problem, or is that like a legitimate problem? We don't know. And this is all really bad. So you get flaky infrastructure with all kinds of sources for flaky infrastructure: Sauce, Jenkins, build slaves, Selenium, Yeti. It's just what's going to fail first. So you're going to have this problem. Tests are flaky for the reasons I talked about earlier, where they work kind of, almost all the time, but it's the one time they don't that's like, productivity sucking, which sucks. The other problem that we saw with that interface is that, and we see this is everywhere. This is in Travis, this is in Jenkins. The most popular build systems all have the problem where they use build numbers, which for the most part aren't really, we just don't care. Like, build numbers are something like, don't answer any question that the developer cares about. The developer cares about, did my commit work? Did my commit pass? Is it functional? And so when you're looking at all these different jobs, you see that they all have different numbers. So you can have this job, which is at 576, and then another job, which is testing the same commit, that has a completely different number. And so there's no way that you can look at this and say, like, that these two things, they might be running the same code, they might not be, and that's terrible. So when you have this many tests, once you start writing a ton of them, you notice that Jenkins will become slower and slower and slower and slower, and it works fine. The problem is, like, it works fine until you come to depend on it. You're wanting instant answers, and it doesn't give you that. It takes over 10 seconds to load something or whatever. And that's pretty bad too. Ultimately, what happens is that nobody's responding to build failures. When you get an email, you don't know what to do, you just do nothing. And then the problems keep going. And about halfway through the year, we had this problem, and it wasn't getting any better. Even though we were doing all this testing and we did all this work, we didn't see any end in sight for like actually improving the quality of our code and like being able to measure it, right? Because it was all over the place. So this had to change. So the solution we made to this is something that we call YO tests. Internally at Yahoo, you actually literally type in yo/tests, and it takes you to this page. You saw it earlier, and I get to show it to you now. But basically what this does, the pain that we had, it fixes that with three things. First, it classifies flaky tests. So yo test understands when something's flaky. And so if something is failing more than one time, we get to flag it as flaky. Like it's something that it shows up the first time that it fails as like a legitimate failure. And then if it's investigated, someone has to stop everything and look at it once something that's stable fails. And if they see like someone updated the README and yet some test is failing, you just mark it as flaky and you can move on with your life. So then you're off the hook, and it goes into a list of flaky tests that we have to review, right? And the list is right now at about 350 or so. So we also don't highlight flaky test results at all. Like, they're there. You can click on a detailed page and get to them, so you can see what failed. But when you're looking at if my commit is good to go or not, you don't need to know if something that has a habit for breaking is actually failing. So we don't alert developers when something that they didn't cause, some bad test that's been around forever, happens to fail when you make a change. And so this prevents people from panicking when there's a bad test. It only it reduces false positives for changes that are made in like a completely different component, and it's a total win. We hide flaky infrastructure. So if something goes wrong that would normally cause like a red build, right, the bad build or failing build, then no one cares. They only care if if the tests are working or not, right? Not if Sauce Labs is down or Selenium flaked out or whatever. It just doesn't matter. So we, because they don't care, we hide that, and that prevents panic from just things that really should go to me because I'm the person responsible and not the entire team or people who are making changes like you guys. So the other thing is we don't have build numbers in here unless you're looking for them. Instead, we focus on commits, the things that you actually are pushing to GitHub.com. So as builds complete, they're organized around commits, which is pretty big. So we can have basically a relationship where we have a commit, right? And then that can have dozens of builds that ran that commit, right? But it kind of turns on its head what CI systems do today, right? Instead of having everything organized by builds, they're organized by a commit that then has these mini builds to it in the interface. So developers know exactly where their code broke. So now when you get this email, instead of looking here and you don't have any idea what to do, you go to YUI tests and you see this page. And I'll give you a minute to look at it, keep this up for a few seconds. But basically with this, the idea is that you can see exactly what the engineers on our team care about right away, which is basically the use of highlight to show that you need to take action with something. If something isn't highlighted on this page, that means you're good or it's not complete yet. When something we know that you need to take action on, it's highlighted. And so we see that the last thing that was pushed to dev3x, the dev3x branch, had a stable unit test failure that shouldn't have failed. And we're seeing that that's actually looked down, and that's actually been happening for a while, and so someone needs to go in and mark it as flaky. The other thing we see right away is that there's environments that haven't ran yet. And like I said, we kind of do the whole rolling up commits into rolling up builds into commits. We do the same thing for organizing all the different test results that we get by environment, right? So because you can have IE6 running all over, on different infrastructure like Sauce Labs or maybe in your own company's Selenium instance. And what we do with the YUI tests is we understand that there might be slight variances in what IE6 identifies itself as, and we all group it together under the same environment, right? So here we can see that no matter what infrastructure is running our tests, we can see that what's still missing because of some kind of infrastructure problem, right? And so even though we have infrastructure problems that have plagued us for right before giving this talk, because I've been working on this talk instead of fixing these infrastructure problems, but we know exactly what's going on here. We know that there's this is just tremendously better and gives people what they actually need to know. If you click on say we just clicked on the first thing, it shows us what this commit was, who committed it, their GitHub avatar. It shows us a list of the 4 tests that failed and what component they're in, name, and what build. So you can click on the build and then go right to the source of the problem. The other thing we have here is this is the many different builds that all contributed to the health of the health report, right? The test report for this commit. So if you want to look and see what happened, you can go click on one of these. What's interesting about this is that you can run many different jobs for the same commit, and then that's shown here. So that's something that a lot of systems don't do. If you run many different builds like in Travis, you can restart builds like in Travis, right? But what this does is we can restart builds and then notice okay, one thing worked here. We see that one test passed and then it failed and then it passed again. And because it's running the same code, that can hint to our system that it's flaky, right? So that's pretty interesting. Like I said before, you can get to all the unstable test failures. You just have to, we don't highlight them, so you have to scroll down and you eventually see them. So as we go and try to fix unstable tests, you can still see that they're there and that they're getting better. And so what this has all done is it's helped us ship more often and ship better quality releases. Things that normally we've missed in releases are caught by this system, and we've been using it since YUI 3.12. But what I'd like to show you really quick, because I'm with the final few minutes I have, is how it helped the most recent release. So the most recent release was on GitHub under a release branch. So this release branch inside of YUI tests, you can just click on, dev3x, or when it's release time, release 3.13.0 appears above it. And if you click on that, you can see this is exactly, a month ago when we released the last version, this is what we used. The rows here, if I just go in and focus on those, we had a problem right before the release where code that shouldn't have been checked in was checked in. And what's really cool is we can go here and it's exactly what we need to know during release time if we're good to go or not. When it came all down to it, the commit that was right before just a package.json change, we see that everything but Android 4 was tested. and we had 0 stable unit failures. And we saw that we had stable sublet failures, but we had to go through them and see, like, no, there actually weren't. These aren't things that would block the release. So that was really good. We had like exactly what we needed to know. And then Android 4 didn't work because of some Sauce Labs, some temporary issue with them. And so we had to test that by hand, but then we were good to go. So, and then this is how we see here that we have way more environments that were tested for that final release. So, so we had a lot more things that were running and working. So briefly, just to recap some things in this interface that I think are key takeaways for people who are building a similar tool or kind of like this kind of thing. We highlight things when you need to care about them. So when something's incomplete, it's gray, but it shows up with a background that's highlighted if it's something that needs to be fixed, like an incomplete environment. That could be a problem with the CI system. And so that's something that I need to pay attention to and look at. If something we don't know, not everything is ran yet, we can say something 0, but we gray it out, and we use that to show that it's incomplete. Highlight when something's wrong and make it red. And then when we know that there's no more browser information that's going to come in and we know we're good, it shows up as green and there's no highlight. So the question we're asking here is, did my commit pass? That's what people care about. To watch their commit as it goes through the system. And with this, we think we got it. We think we just did that, and that's awesome. You go through and you can see that this one didn't, and then you'd have to go through and make changes, and that's awesome. So the key takeaways here, you want to prevent panic from bad tests. When you start testing more, you're going to have bad tests. You're going to find that it might work on 10 different environments, and then you add your Windows Phone or whatever, and it doesn't work. So, what are you going to do? Drop everything and fix that? Probably not. It's really good to collect that data. What's been one of the most biggest benefits we've got from the system is that it's allowed us to basically when we decide what to focus on, we can see, like, even though we're not focusing day to day on flaky tests, we're collecting that data, and so we can see when that this test is failing more often than all the other flaky tests. Out of those 300, there's a couple of them that fail way more often than others, and that's what we need to focus on, right? So, so even though you're collecting test data for things that are flaky and not just ignoring them, setting some kind of ignore flag. We're collecting that, but you're just not panicking everyone with those bad tests. You're preventing panic from bad infrastructure. Usually your engineers don't care about the infrastructure, and one engineer will, and that person should care, but not everyone else, right? And then instead of focusing on build numbers, you should be focusing on what exactly broke, right? So the commit that's breaking. And so how to do this, classify flaky tests. Your CI system should understand what's flaky and what's not when you're starting to ramp up on testing more. Hide flaky tests and infrastructure failures from engineers, and focus on commits. So we're not done with this tool. Like, this is really pretty new. It's only a couple months old. A lot of people are interested in it, and I can't wait to have this available for this community to use directly, right? Even though it's helped us as we decide to ship a YUI release, and we use it to test all the contributions that have been given to us for the last several months. We've been using our new CI system, and then over the last couple months, we've been using this to help us ship better releases. But we're not done. We would love to explore how we can share as much of this as possible with this community. And starting with this talk, where hopefully what you've learned is how some of the pitfalls of doing big doing testing in a really big way, and how you can avoid those pitfalls and test better. So thanks a lot. By the way, this is all made with YUI and Shifter and Jade and other fun stuff, and you can find that all out when you view these slides at reid.in/everywhere. And my name's Reid, and it's been really fun. So thanks, guys.
Thank you. So we have time for a question if anyone has one while we get set up for our next speaker. Let me know. Okay, Reid's going to be around the conference if you want to follow up with him directly. Did you have something? All righty.
I'm just probably going to follow up later with Reid, but I have a quick question for him. How does Jetty fits into the whole into the whole multi-environment, virtual machine kind of thing. So basically, it's the runner that basically kicks on the whole, puts all together with the unit test, with the Selenium, and how that fits into the whole, how the Yeti fits into the whole environment that you just talked about.
Yeah. So Yeti, everything goes through Yeti at some point. And so like we basically are using it in a pretty standard way. Like we have a Yeti hub that that we use, like for example, for Sauce Labs, right? We have a Yeti hub that sits on the internet, and our build system talks to that, and it's basically then Sauce Labs will go through that and then talk to our CI slave. And with Yeti, you can, just out of the box, you can say like connect to this ondemand.saucelabs.com address and start these 3 browsers, and that's what we do. So we start 3 Safari browsers or 3 iOS 6 browsers, and it just kind of handles everything for us. Really quick, one thing that I did do recently is we now have some code that starts a new Yeti hub every time there's a build. So each build has its own copy of Yeti, and that's preventing some flakiness and making some of our builds faster. So we look forward to sharing that once it's working well. So yeah.
Tell people what Yeti is.
Yeah, so if you guys don't know what Yeti is our tool for testing YUI, and not just for YUI, it also works with Mocha, Jasmine, QUnit, and I'm forgetting another one it works with. But yeah, it's basically open source, and you can find out more at yeti.cx. So yeah, it's pretty awesome. So if you are testing JavaScript and want to know how to automate things, it not only works with our huge CI system, but it works really well with small teams and on your computer. And so check it out. Cool. Yeah.